Hello and welcome to another Unity development tutorial. In this tutorial, we will going to be learning about how you can create a user-defined function in which you can pass parameters and also expect to get a value back. So I've created an empty game object, and I'm just continuing with my last example where I have this empty game object called programming object. It is tied to a script called learning programming 1, which is open in Visual Studio. What I'm going to do is I'm going to try to solve a problem to calculate force provided the mass and acceleration are provided, which is a physics formula. So I will going to declare some variables here of type double of force, mass, and acceleration. These will going to be the three variables I'm going to be working with. In the start, I will going to be providing mass equals to a certain value, and acceleration will also going to be of some value. Now I need to calculate force. I could calculate force locally within the start, or I can modularize it. So I can modularize it by creating a method outside called void calc force, which will receive two parameters of type double. I can call them M and A. And then inside the body of this, I can calculate force because it's global variable. I can reference force, and I can say M times A. Now, in this one, you may be wondering, if mass and acceleration are also global, then what's the point of passing them in parameter? You're exactly right. In this case, you should not pass mass and acceleration as parameters because they're global and they're accessible from anywhere. But let's assume that if mass and acceleration were not global, is basically when you will be forced to pass them inside the body from the start into calc force. So now the mass and acceleration are local, so we are assigning them values, and now we're going to call calc force, and we're going to pass mass and acceleration. And this will also going to tell you that when you're passing mass from here to here, it is called what we call parameter. Mass is a parameter, its value will be copied into M. Acceleration is a parameter, its value will be copied into A. So these are variables whose value during the runtime when a call will take place from start to calc force, the values of mass will be copied into M and the value of acceleration will be copied into A. Now you may be wondering, should I name them same or should I name them different? The idea is that it doesn't really matter. So let me change one of them to the same name and one of them to a different name just to show you that names don't matter. They can be named the same, they can be named different. What matters is when the value comes from one parameter into another parameter, they must be of the compatible size to fit the value. So what we call these parameters? We call them actual parameters. And what we call these parameters? We call them formal parameters. So formal parameters receive the values from actual parameters. They receive it. They can do whatever they want to do with those values. It will not change the actual parameters value. So here, after I calculate my force, I would like to display in the log of the debug that the force is calculated as and the value of force. Now this is a very simple calculation, and I purposely did it so that I could understand 10 times 4 is 40, and that is what I should receive as an output. So now let's test it inside this environment. So I'm going to play it, and I expect to get force 40, and that's exactly what I get in the output. Now let me stop it from playing. Let me switch back over to my code, and this time instead of calc force actually displaying the force, I would rather want calc force to simply return a force to the main, and then main will going to then display it. So we call these kind of functions value returning functions. So value returning functions will take a parameter or not take a parameter. It doesn't matter. Their job is to return a value back to the caller, and they can only return a single value back to the caller. And they generally end in a return statement. Return statement followed by what you are returning. Now, the return statement is giving me an error because right now I've said my function is void, that means my function is non-value returning. So I have to change the word void with the data type of force, because the data type stated to the left of the function must match the data type of the returning value. So now start makes a call to calc force calculates force, returns force back into start, and now I need a variable to store the value. Again, the double force, since it's global, there is no point of doing it this way. So again, I'm going to get rid of this global variable, and I'm going to rather put my force down here as local, which will going to make this force error out. So I will going to make it double here to show you that you can perform calculations on a variable right where it is declared. You don't have to do it in two separate lines. Now, there is no point of declaring force here yet because I've not yet used it. That's why it's underlined in green. But as soon as I say force equals to this, now that underline goes away because I am using my variable. Next, I can say debug.log, and I want to display the force, and my force is force. Okay, now if I run this program, the output will going to be exactly the same, but the logic behind the scene is different. That instead of calc force displaying the value and being a non-value returning function, it is now acting as a value returning function. So now when I run this in the game environment, it will going to give me an output, same output, force is 40. No difference in the output. It's just the methodology that I use behind the scene is different. So you can create a value returning function and you can create a non-value returning function. One last thing towards the end of this tutorial is a lot of the developers do it this way, that if a variable is only being used to store a value and being returned right away, they simply eliminate the need of declaring a variable and do it this way. They rather write the return statement in the line where the calculation is getting performed. So you're going to simply delete this, and you will going to rather put this return here, and you will say, okay, after I return, I want to return the product of mass and acceleration. So you're going to just simply return this value right at the point of call. It will calculate the product and return it. Similarly, so if you now run it the way it is right now, if you run it, you're going to get exactly the same output as before, which is force 40. No difference. Okay, so this is more memory efficient, and less instructions is more performance efficient. If they are not planning on doing anything else with this force either, if force is only there to store a value and then display it and will not going to be used in any future instructions in this code, so there is no point of having another memory being used for that purpose. So instead of storing the value in a force and then displaying it, we will rather free up this memory, and we will rather push this whole instruction, we'll cut it from here and write in the output. So as soon as it makes a call, it basically waits for the output to be returned. So calc force makes a call to calc force, passes mass into mass, acceleration into A, and mass times acceleration is performed. The output is returned back to where the call was initiated or generated from, and it is able to display the output. So let me save the changes. Let me go over to the Unity and let me run it, and just so that you can see that you will going to get exactly the same output as before, no difference. So in this tutorial, we pretty much looked at how you can create modules, how you can call them, and it's not like only start can call modules. Any module can call any module. Start only gets called once when the program gets started, and before start await gets called. Update gets called once per frame. So that pretty much is what we looked at in this tutorial, value returning, non-value returning modules. So we're going to be continuing to work with modules a lot in our coming classes. So just so that you know how a module is coded.